Welcome once again to today's live session. Before we dive into our topic for today titled Advanced Programming Techniques, I want to appreciate every one of our participants, the students online. So far, so good. You've been following, and I understand the fact that you are putting in your effort to see that you understand and you partake keenly as regards the robotic class sessions. And also, I believe the project we've been doing so far, you've also done your own aspect, talking about the live moving robots that we did the other time, and also the steerable robots that we're able to make with the, what's it called now, the motors, the batteries, the battery case. What else did we use? The wires, the breadboard, and all that. I believe you have been able to do yours. If you have not, I appeal to you, try and do yours, because it's going to help you a whole lot. It's going to broaden your horizons, and also it's going to spur you up to do more as regards robotics. Today, we are going to be looking at advanced programming techniques. We need to understand that robotics gets more interesting, as it were. Robotics gets sweeter by the codes and what you do. And remember, it has to do with building, designing, constructing, and programming your robot to perform a particular task. And now, not just moving forward, going backward, we're also looking at the turnings, we're also looking at complex programs, we're also looking at advanced programming techniques that will empower or enable your robot to do beyond the normal. You agree with me that in today's rapidly evolving technological world, basic programming skills are no longer enough to solve complex real-world problems. And what are we saying? What we're doing today, it empowers learners to think critically, design smarter systems, and build more responsive and intelligent robots. For when we talk about robotics, remember, we can use different platforms. We can use the PictoBlocks, we can use the EV3, we can use a whole lot of things. A lot of things can be used. A whole lot of robotics kits can be used to be able to perform and meet up this task ahead of us. But using PictoBlocks for today, it's a powerful block-based and Python-friendly programming platform that learners can move beyond simple motion commands and LED displays to explore sophisticated concepts. And what are these concepts? We're looking at custom functions, move forward, move backward functions, nested logics, sensor integrations, and even artificial intelligence and what we call IoT, Internet of Things. In today's module, we will dive deeper into how these advanced techniques can be applied in robotic education. We're going to be using the Quirky kit or similar programming robots. I believe you will learn how to structure complex algorithms, manage multiple inputs and outputs, and develop robots that are not only reactive, but also will be able to help us to do what we want to do. Okay, quickly, let's go forward. All right, what are our lesson objectives? We're going to look at advanced control structures and logic blocks, and also integrating artificial intelligence. Okay, let's move forward. All right, when we say advanced control structures and logic blocks, talking about coding, programming. For example, if you look at your PictoBlocks environment, we are using PictoBlocks because majority of us are familiar with it, and we can use our phones, we can use our laptops, we can use our tabs to connect to it. Okay, that's why we're using PictoBlocks for today's advanced programming techniques session. Now, we're learning how to write smarter and more organized programs for our robot using PictoBlocks. And what is our goal? To understand and use advanced control structures like nested loop, if-else conditions, switch blocks, loop blocks, and custom blocks. Number one, loops. When we say loops, you can see loops on EV3 and others. You can see forever on PictoBlocks and others. Now, what does it mean? A loop placed inside another loop. Okay? Use case, repeating a repeated action like continuously checking a sensor while a robot is moving. How can we find that? Quickly, let's go to our PictoBlocks block. Okay, I stop sharing and let me share my PictoBlocks. Where's my PictoBlocks? Okay, thank you. Okay, this is it. Now I believe you can see my PictoBlocks. This is PictoBlocks platform. What do we do now? You can see for me to go to my PictoBlocks, what's it called now? Loop or forever. Come here, go to control, click your control. Wow, that is it. What do we have here? Forever. Now look at it, bring up your forever. Any block in this forever block, it simply means that the program will continue to run continuously. For example, this is forever block. I can choose to bring in my movement. Let me say bird. I choose Quacky. Okay. And I go to robots, excuse me. Before that, I can put my when clicked, then I go to control. You can see wait, repeat, forever. I put my forever block. Can you see that? I can also go up here and I take my motto under robots, my motto, meaning go forward. I bring this in, look at it, into my forever. You know what this means? If I play this program, this robot will continue to move forever. This is an advanced programming technique. Forever. It will not stop until the battery is dead. For example, now you can see that forever does not have any control. No number. Now, if I don't want to use forever block, you can see that I remove that. Let's go to something else. Let's say repeat. I can put repeat now. Repeat now is like forever, but it has an imputation for a particular digit. I can say 5. 5 meaning, and I put my go forward. Can you see that? For this now, if I play it, the robot will move 5 times. It will perform the task on this move forward, but 5 times. Do you get that? Thank you very much. Okay, let me stop sharing so I can go back to my slide. Thank you very much. If you don't understand, feel free, drop your conversation on the chat box and I will pick it up from there. All right. Thank you very much. Okay, now I'm sure you can see my screen. So that is for loop. The same thing, if else system. If else system works using one if else block inside another to check multiple conditions. To check multiple conditions. All right. Now that is what happens to check multiple conditions. What does that mean? You are saying, example, if my robot is seeing a blue color, keep moving forward. Or else reverse backward. Can you see that? If then else. If my robot is seeing a blue color, the sensor is seeing a blue color, keep moving forward. Or else turn backwards. That's the function for this advanced control structure called if then else. You also find it on your PictoBlocks. You can check out for it on the control panel. You will see it there, and you will see if then else. You will see repeat. You will see function. You will see forever. All right. Another one we have here quickly is the custom blocks. Custom blocks is what we call the blocks. I can do a lot of programs, and I will infuse everything into what I call block. I can name them a particular name. It's a user-defined block that groups instructions and can be reused. Another one is the line following block. In PictoBlocks, you have an advanced programming technique called the line following block. In PictoBlock, it is used to automate the movement of a robot. Example, like Quacky. What does the Quacky robot do? To follow a black line or a white surface or vice versa using its infrared sensors. Using its infrared sensors. That is what happens with this. Okay, let's move on quickly. I need you to understand we can also integrate artificial intelligence AI in PictoBlocks. The PictoBlocks robots, okay, allow students to create smart interactive projects by simulating human-like abilities, such as number 1, face detection. You can program your robot, the quacky robot on PictoBlocks, and your camera is on you, and you look at it. And while you look at it, it will. If you frown, the robot is going to show you a frowning emoji. If you smile, the robot will show you a smiling emoji. That's the function of artificial intelligence in it. How can we integrate it? That's what I want to show you quickly now. Follow me closely. How can you integrate it? What do you need to do? Number one, enable AI extension. How do you do that? Open your PictoBlocks, go to extension tabs, and add the AI related extensions like, okay? Go to the extension tabs, add AI related extension like, okay? Number one, we have face detection, teachable machine, pose detection, speech recognition. Yes, your robot, when you talk, it can notify you that the name of the person that is speaking is this and this and this. Why? Because you have registered the face and you have registered the name of the person. Do you understand my point? That is the way it works. Now, how do we attain that? Look at this now. Where's the PictoBlocks? Okay. Okay, you can see your options here. When you click them, what do? You are able to install, you're able to add up other extensions that you want to use for your PictoBlocks. And when you add up these extensions, it's going to help you a whole lot to be able to, it's going to help you to be able to do some advanced programming techniques that will give you a better understanding. All right. Okay, let's move on. Okay, good. So how do we do that? Add your AI extension. Okay, when you add the extension, pick up the whatever one you want, face detection, the machine, pose detection, and all that. Then what do you do next? Train or use a model. I would advise you to use Teachable Machines by Google or PictoBlocks built-in tools to train a model using images, sound, and gestures. For example, now we are going to look at how you can put up a line following program. Very, very simple. Let's progress to that. All right. Okay. So listen to this now. Okay. All right. Still looking on and working on advanced programming techniques. I'm launching my PictoBlock software right away. You can see that it is loading. The advanced programming technique we are going to be working on today, we are going to be using PictoBlocks strictly because we want everyone to be a part of this, not complaining that oh my I don't have a, what's it called now, a software that will be able to do this, okay, or I don't have a laptop. With your phone you can run this with your phone, so it's not a problem. Okay, with your phone you can do this. All right, so we kickstart right away. How we want to do an advanced programming technique, and what we want to achieve is very simple: applying complex program blocks to see that we're able to synchronize different blocks to achieve a task. And one of those tasks is a line following code. And let's go now. Very simple. I don't want the video to be long so that you can watch it and prepare your questions. First thing first, you go to your IR sensor threshold. Remember, you click your board, you select Quacky, right? You select Quacky, and you on your robot and you connect. But here, we're not using the robot now because most of you do not have the robot. So I need you to just do the block and confirm that it is correct. You come here, you go to robots, you can see click robot. When you click robot, here you are, you have all your blocks here right away. So first first thing first, you go to your IR sensor threshold. Look at it. IR sensor threshold. You bring it out 1. You see that? Here we go. Set this to left. Okay. Take your values to, let's say, 600. Okay. 600. Take another one. This is for left. IR means um, infrared sensor. Okay, the left one. Then you pick up another one. You can see that. Now you change this one to right. Infrared changes to what? 600. As the case may be. Very quick. Next one, you go to set parameters. Okay, you set your parameters. That's for the sensors. What is it going to read? Okay, for the sensors in between the white and the black lines, we have the F, T1 and T2. Okay, we could leave this at 30. We could set this to, let's say, 50, and we could set the third one to, say, 25. Okay, that's it. And now remember, it's going to be continuous. It's going to be continuous. What do you do next? Because it's going to be continuous, you can now come and say forever. You come to control to pick up your forever block. You can see that here. Pick up the forever block, and here you go. Then what do? Insert, do line following. Do line following. Do line following. Okay. Do line following. Look at it here. Insert it inside. You can see that. After that, what's the next one? Go forward, because your robot will keep moving. All right. All right. So now, very simple. I don't want the video to be long, so that you can. Here we go. Set this to left. Okay. Forever following. Look at it here. Oh, you can see this simple line following. Don't make the speed too much. Just make it insert it inside. You can see that. After that, what's the next one? Go forward, because your robot will keep moving forward. You pick up this and you insert inside the do line following. Don't make the speed too much. Just make it on. Put it to 30, and here you go. You can see this simple line following program. Line following program. You can see that. All you need to remember from the very beginning, you have to add up your events. That's your flag, your green. That is it. Okay, so with this, you just click this and you see your robot is moving. Okay, that is it. You can see that. All right, thank you very much. So duplicate the same on your PictoBlocks app on your phone, and also list out the steps on how you're able to achieve yours. Best of luck. Let me see what you were able to do. All right. Still looking on and working on programming technique. We are going to start right away. How you can see that it is low from the program codes we did and you watched from the first video you just saw. This is the outcome of it. Right here, my Quacky is on the ground and on the mat with a black and white line. You can see my robot moving, following the black line, and you can see the parameters indicating green and red light very closely. Green and red light, you can see it. When it is on the black line, it's showing a blue, a green. When it is out, it's showing a red, and it is following it accurately. So that is what you get if you do the block correctly. But meanwhile, I know you might not have the Quacky Robotics kit, but go ahead and just place your own blocks correctly and let me know the steps you took, how you were able to achieve that. Do from the all right, thank you very much. Okay, thank you. So, from the video you watch, you've seen that we've been able to see how to put up the code for a complex line following advanced programming technique, and we're also able to see the outcome of the task, what it looks like when you use the robot video. Okay, so now this is your class activity. Watch the first video, place the video you have watched, place your own program blocks exactly the way I did in the first video you have watched using the PictoBlocks app software in your phone or PC. Right click on the program blocks you have arranged on your PictoBlocks environment. 4, click export block as image, then save on your phone or PC. Send the saved image of the block program you have done to the online platform for submission. So what you're going to do is, I'm sure this live session is recorded. You can go and rewatch it. When you rewatch it, then you can do the same thing I have done, then export it as an image. Let me see for confirmation. Okay, and also you can access online resources online on advanced programming techniques, just like the assignment I gave to you in the introductory section that we had last week. Okay, you can get open educational resources from this website and also on YouTube. Thank you very much. I don't know if you have any questions, you can pop it up on the chat box so that I can access it right there. If there's any question, feel free to drop it on the chat box so I can respond to it. Thank you.